There are two other things that I want to talk about. The first one is notation of forces. Notation. I think I've mentioned. I've explained this. So in chapters 4 and 6. And in chapters 4 and 6, we have many ways. We have different ways to write down forces. So, and here I just want to organize them a bit. I want to organize them a bit, okay? And the first thing is support. Like pin joint, pin support or roller, pin support or roller support. So for this is you can see this in chapter 4. For this support that the pin support, roller support, this thing. This is in chapter 4. So please you need to write down directions of the forces like 100 Newton going up or 200 Newton going to like 15 degrees. Okay, but these are the support forces. That remember to write down the directions of support forces. And that's the first type. For the second type, for trusses, that's like your spaghetti bridge, like these trusses, and for forces in members, like forces in members, which is this. How do we mark these forces? They can be in compression or they can be in tension. So we write how to write. We mark tension 100 Newton T. Okay, or 200 Newton for compression. How do we write them? C. Very good. And at the beginning of this in solving this problem, that assume all members. So at the beginning, when we draw 3-point diagrams, assume all members are in tension or compression. 一开始的时候，假设是 tension or compression, tension, okay? So for a particular joint, for example, joint A, that all forces are going out, okay? And T, A, B, and T, A, C, and so on. It's okay. So you need to remember this in your examination. And the last group is for frames, that we determine forces at joints or forces between members. So for forces between members, and you can see, look at the textbook, and so you draw AX or AY here. That, but for example, in answers, that we only write magnitude, and we do not write direction in answers. Okay. We do not write directions in answers, so you only write the magnitude of the forces. Okay. Now, if you are finished writing this down this table, then you can go to the next page. Any questions up to now? 有没有问题？ So if not, that we go to so take your time to write this, and after that go to the next page. So we go to the next page. As I've said that you can see this in a motorcycle or car repair shop, that it is a hydraulic lift table. Hydraulic is hydraulic, and the accent is on here, hydraulic. And to raise a 1,000-kilogram crate, and it consists of a platform and two identical linkages on and these exert equal forces. And so it has two sides. It has two sides. As a car repair shop, we have two sides, and only one is shown here. It has two linkages, and only one is shown. Okay. And members EDB and CG are length of 2A. CG is 2A, and EDB is also 2A. And member AD is pinned to the midpoint of EDB. And so for this equation, for this question, sorry. Look for the word, if this is so long, if this question is so long, then which word should we look for? Determine. So what should we determine? Determine the force exerted by each cylinder in raising the crate. Cylinder is this one. Okay. So there should be a force to support this structure, right? So for theta equal to 60 degrees, A equal to 0.7 meter, L equal to 3.2 meters, determine the force here, okay? And show that the result obtained is independent of the distance d. So show that the result obtained is independent of the distance d. Independent of, do you know what does it mean? 无关哈，无关或独立。It's okay. So you have seen this in you can see this in a car repair shop, and so it needs a cylinder to push it to push the structure up. Okay. You need this DH to push the structure going up. So now we need to determine the force acted by this cylinder. So how much is the force pushing the structure up to greater equal to 60 degrees? Okay. Now, to begin with our calculations, we first need to list all the rigid bodies we have. Okay. We first list out all the rigid bodies we have. What do we have? This is one bar here, AD. This is AD. And then what else? Any others? Any others? BE or BDE, very good. Others? CG, and we have BC, and we have what else? We have DH, and it is structured. It is not. It can change its length, but just we first write it down, and then the last one is ABJC. J is the point where this force is acting on this platform. Give me a minute that I want to show you. A video. Wait a minute. Just give me a minute. Oops, sorry. Let me. Where is it? Wait a minute. Give me a second. So it is. Give me a minute and. Where is it? Oh, right. And so let me show you how does it look like, because this is so go to my channel and so it looks like something like this. That's this is AD. This one is AD, and this one is BDE, and this is CG, and this DH, and this is BC. So this one is a platform that can go up and down. Oh, sorry. Of course, you can go up and down like this, but wait a minute. And what else? And I think I have. Oops. Yeah. Wait a minute. I have another. Right. So in a car repair shop that we have this one, right? So when it goes up and down, then this platform. So does it look better here? Okay. So when it goes up and down, then this platform is it can slide against so these points B and C can move along here. Okay. So this is parallelogram, and it can go up and down. And this one is this is not these 2 points are not fixed to the platform. These 2 points lie on the platform. It's okay. Let's before we start our